brought with her some staff and students this evening who are going to share a little bit about their robotics program and how that's connecting to our STEM focus and some project-based learning. So, Dr. Marion, the floor is yours.
Thank you, Dr. Crosby. President Castry, we will share all of that. This is for SETI. President Castry, members of the board, thank you for the opportunity for us to be here tonight to share with you about our robotics program. I have Tom Zook with me tonight. He is our advisor for our robotics program, and he's also a teacher at Marina High School of Physics. And we also have 4 members of our leadership team of our program. And they're going to talk to you about what it takes to run a robotics program, what kind of skills that they're able to develop as they work in that program, how that's connected to the curriculum during the school day, and also how it extends the learning outside of the school day. And then we're going to do a little demonstration for you so you get to see how the robot works. So it's my pleasure to introduce to you Tom Zook.
Thank you, Dr. Marion. Thank you to the members of the board for allowing us to bring a robot into a board meeting. Yes, as Dr. Marion stated, in addition to teaching physics, I'm also the faculty advisor for the first robotics competition team 4276, which you see on our shirts, the Surf City Vikings at Marina High School. The first robotics competition is a international high school robotics competition that challenges students under the mentorship of teachers and industry professionals to build, design, prototype, and build a robot within a very, very narrow set of specifications for a novel game every single year. The students that I brought with me tonight, Riker Barthold, Avery Levin, Jacob Wiedner, and Arthur Ho, represent team leadership, and they're going to run through what they do on sometimes daily basis to help make the team run as smoothly.
Hello, I'm Riker Barthold, design lead for Marine Robotics team. So what that means is I'm leading the design effort, which starts off with our prototyping phase, where we're coming up with ideas, brainstorming with other mentors, industry professionals, to figure out what's the best way to complete our tasks. After that, we move on to our secondary phase, where we're designing our robot in industry-grade 3D modeling software. So before we ever cut any parts, it's all made in a virtual space. During that phase, it's a great time to double-check all of our mechanisms, make sure that all the physics behind everything works. So that's where we use our application of mathematics, physics, and other STEM curriculum to double-check everything. So for this year, the wiffle balls that you see in the robot, we had to reach into a goal of several feet off the ground. So we had to find the perfect trajectory to reach that. So that's where we use some physics for that. After that, we go into our manufacturing phase, where we are producing all the products and then constructing the robot. Whether that's powder coating or just bolting parts together. However, there's one main component left, and that's software design, and that's where our software lead will take over.
I'm Avery Levin, and I'm the software lead on the team. And basically what that means is I'm in charge of heading the team's programming and wiring efforts throughout the season. Through our team's software and electronic applications, we receive great hands-on experience in the STEM fields. And on the robotics team, we often utilize the information we learn in our math and science classes, as well as expand beyond these courses into areas that the current school courses do not cover. For example, programming an autonomous routine for this robot could incorporate different subjects from calculus, trigonometry, physics, and even some advanced computer science topics that are beyond the high school level. Each fall, the older members of the team train the newer ones in the different areas that go into the technical build of the robot. And in just the programming and wiring alone, the students gain considerable hands-on experience and knowledge of the different sensors and actuators we're using on the robot. While drawing on the equations and subjects taught in schools, this project-based learning has allowed for students to understand not only how the actuators and sensors work, but also what their applications are in the real world. from both a software and hardware point of view. So in order to teach and develop these skills, we rely heavily on our student leadership and the many resources that our team needs. And here to talk about that is Jacob Wiedner.
I'm Jacob Wiedner. I'm the team president. I work on team organization and project management. We're a student-led team that is mentored by industry professionals, and they help us to design parts, program, and build the robot. And this means that we get to work with mechanical and software engineers with building the robots, which is a fantastic experience. I also work on the financial part of the team. We spend about $20,000 each year on materials and registration fees. And so I obtain sponsors and plan fundraisers each year to cover these expenses. Our sponsors also help us to manufacture parts that we wouldn't be able to produce otherwise by donating their services. And here to talk to you about media and outreach is Arthur.
I'm Arthur Ho. I manage the business and media aspect of the team. For business, I work on the team newsletters as well as the team's social media. And for community outreach, I plan demos as well as events. So going into the newsletter, our general audience are the parents that are sponsors of the team. And for social media, that our general audience for that is our high school, other high schools, and other students. For community outreach, we've held industry demos, and the goal of that is to obtain mentors in the professional field. And we've hosted events at local schools such as Stacy Middle School and Springfield Middle School. And the goal of that is to introduce middle school students to real-world application of science and mathematics. At Marina High School, we've hosted an off-season event called Beach Blitz, and the main aspect of the competition is the workshops. And the workshops allow teams to exchange information regarding to science and mathematics. We will continue to plan demos and host events. And back to Mr. Simon.
Thank you, Arthur and team. As you can see, these guys are pretty passionate about what they do, and I also like to commend them. This is their first time talking in front of the school board, I believe. I forgot to mention that the robot for SETI that's in front of us, the intention for the 2017 game that this was in competition for, had multiple aspects that had to do with very complicated game, but one of them was picking up and delivering a gear to Peatman players, another was shooting the wiffle balls, as Riker mentioned, as well as to climb a rope to a height of 4 feet above the ground at the end of the game. The students are currently working, we're 1 week into our 6-week build season for the 2018 game, so we don't have a robot for that yet, but they're working really hard on it, and in addition to that, they're also working, as Arthur mentioned, with other teams, including new rookie team at Fountain Valley High School this year, bringing us to a total of 5 to 6 schools in this district having first robotics competition teams. So I'd personally like to thank you again for letting us talk.
So as you can see, we have an advisor who has dedicated countless hours of his time to this program, and we just have incredible students who also dedicate countless hours to this program and have really gotten a lot out of it and really given a lot to the school. So at this time, all of them are prepared to answer any of your questions and to show you a little bit what the robot can do. We're going to be careful about flinging balls around the boardroom, but they can drive it around and show you. It just was very loud to do it while we were talking. Do you guys want to drive it a little?
And if those in the audience would like to stand up so you can see, please do.
It's a very short robot.
Sling away.
Major components of any game of First Robotics is that the game pieces, once you touch them, you want to own them. You don't want anybody else taking it away. So the students designed that gear mechanism to grab on the gear and pull it out of the way of any other robot that might try to take it. That is the shooter motors. We're afraid that the balls might hit the ceiling and dislodge sometimes. We've had some trouble getting it's usually adjustable. They did all the work programming so that adjustable speeds, but I think there's a wire in the wrong place. We can't quite track it down right now.
And if you've ever been to a robotics competition, all of these robots are doing all of these things really quickly, all at the same time. So it's really fun and really fast. And I still don't understand how they keep track of all of those points, but they do. And these guys just work like crazy the whole time, and they problem solve and troubleshoot just like they have to do with the shooter right now. So I'm gonna let these guys come up, so if you have any questions, you can ask them.
First of all, thank you very much. It's extremely interesting and certainly not what I was doing when I was in high school. Do my colleagues on the board have questions?
Oh, yes.
Dr. Dishno?
I have a few. Are you guys seniors or juniors? What's your grade in school?
I'm a junior.
I'm a junior. So all four of you juniors?
We have one senior.
Because part of my question, or another related question is, how long did, from concept to what we see here tonight, how long did that take?
So we get 6 weeks to design, build, and program the robot after we know what the game is that the robot has to build.
That's pretty fast. When you guys are all world-renowned scientists, will you come back to Marina and share your expertise with students at that time? I wanted to ask, are we going to see this in the STEAM fair
Yes, we should.
later in the year?
We should all be at the STEAM. All the robotics teams at the STEAM fair this year.
And then my other question, I see some of the sponsors' names on there, and one of you mentioned that when you were speaking to us in your remarks. Did some of these firms who sponsored you, did they provide people to assist you as you were developing this?
Yeah, mostly from Boeing, just aerospace engineers in general, some software engineers as well. We do have one, I think he's studying engineering after college, that we met at, Pomona, yes, Pomona College. So he's currently becoming an engineer, but we met him at one of our outreach events.
And my last question is, the competition that you designed this for, that's over now?
Yes.
And
Yeah.
and tell me again how you did.
In OC, we were semifinalists. Sorry, not OC, CVR. OC, we placed second, and then we got booted out in the quarterfinals. And then we went to Worlds, and I believe we were ranked 16th, and we didn't make it quite into qualifications.
Congratulations.
Does anyone else have questions? Mrs. Iverson?
Couple questions. One, when you were figuring out your trajectories for your balls, did you do that by equation or did you do it by trial and error?
Equation. We found out, someone found out the air resistance for the balls, and then we actually plugged into an equation.
An interesting integration of the software with what he's talking about is once we found out the physics equation for the trajectory of the balls, we could actually, we used a separate software program, MATLAB, to graph out the trajectory of the ball. So while just crunching numbers, we were able to make like a graphic representation of it and figure out with what the different powers and angles of attack would be best for the shooting. So.
How close were your calculations to the actuality?
They came pretty close. Overall, we made most of the shots. Of course, there are variances in the system, and one thing we have to deal with is as more balls go through the shooter, it slows down, and that comes in with the programming. We have to create what we call PID loops, which are basically they're reacting to a changing system, and basically trying to keep it at that steady rate to be able to shoot the balls as accurately as possible.
Cool. Next question. How much of that robot you have in front of you, are you going to be able to salvage for your next robot, or will you have to start all over?
Most of the motors and stuff like that we can't really reuse, same with the aluminum. But however, for like our practice robots, we'd like to build like 2 robots per year. We will use the motors from there. We just want fresh gearboxes and motors so we can ensure that nothing's going to break down during the competition.
Can that be bad?
Yeah.
How
Dr.
high and how
Simmons?
far did the ball have to go?
I believe it was 7 or 8 feet off the ground, and only about, I'm gonna say 2 feet in distance. But a large volume of balls. I think it was, in order for you to gain a certain amount of points, you had to get about 300 balls into the goal.
Yeah, Russ, if you could put us on your newsletter distribution site, we'd certainly like to be able to follow you, and we all know different people in different industries, and maybe there's something that we could help you out with sometime, so keep us informed.
Which made me have another question. That's not 300 balls. How'd you get the other balls? Where did they come from and how are they associated with that?
Yeah, so on the arm where it's intaking the gear, there's a set of rollers on the bottom. So we actually drive over, usually the field will be filled with balls.
Okay.
So we'll drive over and we'll just collect balls as we do our what we call gear runs, where we're just going back and forth across the field.
Okay, got it.
You want me guys want?
So you do some shooting and then you go collect balls and you shoot some more and go collect balls. Got it. Perfect.
So Avery's gonna try to drive forward and make that happen.
You went Semulus.
It's only 1 out of 300.
Cool. Thank you.
Thank you, Mrs. Henry. Did you have any questions or comments? Okay. Thank you very, very much. And I still do want to know, is there a name for this little guy? Do you know his name?
This robot's named Forsetti, which is after the
Forsetti?
Forsetti is after the Norse god of justice.
It's kind of like a superstitious thing we have on the team with naming our robots after the Norse gods because we're the Vikings. So it's a little superstitious because every year we've named our robots after a Norse god. We've gone to world championships, so hoping to keep that tradition going.
Still name them after the guys on the Vikings show.
Sounds like a good tradition to keep.
Yeah.
And congratulations. You're certainly doing wonderful work, and thank you all very, very much. We continue to be a district that innovates and wants to keep our students learning and really excited about learning because it's a lifelong process. So thanks a million.
Thank you.
Thank you.